Okay, so we're going to continue this series on solving equations. And so far we've been solving linear equations and some rational equations. Rational equations, of course, equations involving fractions. And we've done some inequalities. And so we're going to continue along those veins. And the one thing we learned for sure is when you solve equations, you use the just a minute, equations. You use the properties of equality, the addition property of equality, the subtraction property of equality, etc., which basically says if you do the same thing to both sides of the equation, the new equation is equivalent, is equivalent to the old equation. So as we've seen before, if you have 3x plus 7 is equal to 8, no, how about negative 8? Then if we subtract 7 from both sides, that's doing the same thing to both sides of the equation. That would give me 3x is equal to negative 15. Divide both sides by 3, and we get x is equal to negative 5. So that's the basic method for solving equations. And if we have variables on both sides, we've got to get them together, etc. So we're going to look at a new class of equations. Like, for example, if we had 3x squared plus 7x, or plus 7 is equal to, let's see, let's do a negative 7 plus 5. Okay. So once again, this is just an equation. So we're trying to get x by itself. And in this case, I want to proceed like normal. I would undo the outside stuff first. So the first thing that's done to x, if I plug a number in for x, the first thing you do to it is square it. The second thing you do to it is multiply by 3. And the third thing you do to it is add or subtract 7 from it. So the first thing we're going to undo is the subtract 7. So we're going to add 7 to both sides. That's how you undo a minus 7. And you get 3x squared is equal to 12. Okay? Next thing we do is get rid of the times 3. So how do you undo times 3? By dividing by 3, and we get x squared is equal to 4. And now we come to a situation that we haven't seen before so far in this class. We have the x is still not by itself. It has a squared attached to it. So we have to somehow undo the squared so we can actually see what the actual x is. This is telling us what x squared is. We want to know what actually x is. So to finish this off, what we can do is we can square root both sides. Because when you square root x squared, we all know that the square root of x squared is x, isn't it? So I'm going to square root both sides. And when I do that, I get x is equal to a 2. But now keep in mind, we know that negative 2 times negative 2 is equal to 4. And 2 times 2 is equal to 4. So when I square root 4, there's actually two possibilities. So my answer is 2 or negative 2. And again, if you just want to check, you can throw those in. So let's check 2. That'd be 3 times 2 squared minus 7 is supposed to be equal to 5, right? And so that would be 3 times 4 minus 7 is supposed to be equal to 5. 3 times 4 is 12. And sure enough, 12 minus 7 is equal to 5, isn't it? But if we check negative 2, then we go 3 times negative 2 squared minus 7 equals 5. Does it? And of course, negative 2 squared is also 4. So that'd be 3 times 4 minus 7. And once again, we get the same thing. 12 minus 7 is equal to 5. So both of them check out. So in this case, there's actually two solutions. All the equations we've solved so far have either had one solution, no solutions, or infinite many solutions, right? Here, there's another option because of that squared. Actually, there's a potential that we could have two solutions. Okay, so let's continue on here. Let's say that we have x minus 3 times x plus 3 minus 8 is equal to 10. So here, in this case, we'd have to get, we're going to have to do some simplifying, aren't we? So x times x is x squared, and x times 3 is 3x, and negative 3 times x is negative 3x, negative 3 times 3 is negative 9, minus 8 is equal to 10. So then notice that the 3x minus 3x is 0, so we end up with an x squared minus 17 equal to 10. So then we add 17 to both sides, and we get x squared is equal to 27. So far, so good. And now we're back to this same situation up here where we have an x. We know what x squared equals, but we don't want to know what x squared equals. We want to know what x equals. So we're going to go ahead and take the square root of both sides, and we get x is equal to the square root of 27 or negative square root of 27. Okay? Now, of course, we wouldn't leave it like that because we've learned how to simplify radicals, right? Because there's a perfect square factor in there. So this would actually be x equals 3 rad 3 or negative 3 rad 3. Because the square root of 27 can be written as the square root of 9 times the square root of 3, and the square root of 9 is 3. Okay? So that would be my final answer. And it doesn't matter which side of the sign of the equation the variable's on. So we could have like, I don't know, 5 is equal to negative x squared plus 14. So I would, of course, first I want to get x by itself, so I'd subtract 14 from both sides, and that would be negative 9 is equal to negative x squared. And I would then, I want to get rid of that negative before I square root, because I don't want to square root a negative number. So I would multiply by negative 1 or divide by negative 1, and that would give me 9 is equal to x squared. And then I'd square root both sides, and I would get 3 or negative 3 is equal to x. So these equations we've been doing, you notice, are not linear. These are what are called quadratic equations. And that's really the focus for the next several videos. These are called quadratic equations because they have an x squared in them. If they had just have a x without any powers, those are linear. These are quadratic. Okay, so we'll continue. Let me do one more example. So let's say we have x squared plus 7x plus 12 equals 0. Okay, so now this is another quadratic equation, but notice when we go to try to solve this, first of all, we notice there's two x's there, right? So I want to get the x's together, but there's a problem. I can't get the x's together because these are not like terms. So my normal methods of just undoing everything, like you could subtract 12 from both sides and you get x squared plus 7x equals negative 12. And then what do you do next? Well, there's nothing you can do because, again, if I divide everything by 7 to get rid of that 7, notice we get x squared over 7 plus x is equal to negative 12 sevenths. And that didn't help at all, did it? Because then I want to get rid of that 7. So I'd have to multiply everything by 7. Of course, that would take me right back where I started. I also can't square root right here because if I square root that, it doesn't turn into just an x, right? Because we have a plus in there. We can't distribute the square roots. So this, we need a new method. So I'm going to end the video here, kind of the cliffhanger. In the next video, we'll talk about what do we do if we run in one like this. Now, but before we end it, let's notice the difference. Notice on these, there was only x squared. Yeah, it looked like there might be some x's on this one, but then they canceled each other out, right? So the 3 examples I've done so far, they had just an x squared and no x in the equation, right? So this one, the difference is, notice there's an x squared and an x.